Hi everyone, hope everybody is doing fine and safe. In this video lecture, I want to go over estimation and confidence intervals. So basically, that's a very big topic in statistics, estimation. But before we start, let's see what we can estimate in statistics and uh, why do we estimate in statistics. Now we have learned so far in statistics, we have sample and we have population. So we said the mean, if it's the mean of a sample, it's x bar, the standard deviation is denoted as S, and the sample proportion is just percentages. When I say 30% of Americans drink coffee in the morning, so that's the proportion. So for sample, we use p hat, and for population, we use p. Same, we learned the population mean is mu, the population standard deviation is sigma. So now the difference between sample and population, first of all, just know that these are called sample statistics. And I put a note for you here. We can calculate. Usually sample is small, and we can calculate. There are formulas available to calculate the sample statistics. These are called population parameters. Population can be small or can be large. When it's small, we can deal with that. But when it's large, let's say if we have 10,000, 20,000 people, and we want to know an information about all 10,000, 20,000, or 100,000 people, it's not easy to survey or do the calculations. So what we do, we can estimate them. And these are, again, population parameters. So what do we estimate in statistics? The first thing I want you to know are the population parameters. Let's see how that's done. This is a little example to understand about estimation. Let's say our class takes a test and I calculate the mean and it's 70. My question is, what would be the mean for all statistics students if all statistics students take the same exam or the same test? Let's say we have 15,000 students, and if they take the same exam, what would be the average? And again, that's not very easy. It's possible, but not very easy to calculate. So what we're going to do, we're going to estimate that. The population mean is one number, but we don't know that number is, so there's some probabilities to get that number. So what we need, what we say, we create a confidence interval. So I can say the population mean, or the mean of those 15, 20,000 students taking the same exam will be a number between 65 and 75. Why did I say 65 and 75? Because I know the average of our class is 70, so it will be a number around 70. If I don't have this number, then I can say it's going to be a number between 0 and 100. So it's not very close. Now I said 65, that's 70 minus 5. That was just my choice, and 70 plus 5. Here 5 is called the margin of error. So I put E is plus or minus 5, and this is the interval. You can also write that in interval notation. One more time, I just guessed 5 for this example, but there are formulas to calculate the margin of error. So let's see. First, we need to know to estimate the population mean, we have to know the sample mean. Just like the example we did. I have to know X bar in order to find this confidence interval or to estimate the population mean. To estimate population standard deviation, we have to know S, so which is the sample standard deviation. To estimate the population proportion P, we have to know P hat, which is the sample proportion. So in statistics, the way you say that, you say X bar is the point estimate of mu. S is the point estimate of sigma, and P hat is the point estimate of P. So remember point estimate. Now, when we start, let's get into formulas slowly. So the first thing I want you to know is confidence level. In order to estimate, we have to know the confidence level. So the confidence level, I'll just in this video go over how to find the critical values when we are given a confidence level and how we can use the confidence level to estimate. Then I'll go over the theory in another video and how where this is coming from. So now confidence level, I want you to remember it's when we have, for example, the standard normal distribution. Remember, we did that in the last chapter for the last exam. The mean is 0 and the standard deviation is 1. So if we put the confidence level is the area right in the middle. And we want to know those Z values. These are called the critical values. Now, the middle area, the one that I shaded in red, is called confidence level. However, we have a couple of areas here in the tails. If you add those areas, you get alpha. So that's the notation. So, but in each tail, you have alpha divided by 2, and these are usually small areas, and these are called significance level. So when you estimate, you have to know confidence level. Later on for hypothesis testing, we have to know the significance level. They are kind of related, but I just want you to know this notation and the difference between confidence level and significance level. One more time, confidence level is the area in the middle, and significance level are the areas in the tails. So sometimes it could be in one tail only, but for confidence level, it's always you have two tails. Z are the critical values. We learned how to find those, especially using the calculator is very fast. But something new, since this is alpha, the area in the tails is alpha, those Z's, we're gonna call them Z sub alpha over 2 from now on. So in statistics, they don't just say Z, they say Z sub alpha over 2, and alpha depends what area is in each tail, alpha over 2, basically. And one more time, these are critical values. I put the note for you, alpha is the Greek letter alpha, it's called significance level, and it's the area in the tail or tails. The Z values are called critical values. In statistics, we write Z sub alpha over 2. And the notation is like a fish. That's alpha. Now let's do some examples. First, you need to be very comfortable in finding the critical values. So first example, I said find the critical Z values for 90% confidence level. So to find that, draw the curve. 90%, we know it's the area right in the middle, but we need to know this area in the tail or to the right of this value in order to use our calculator. That area is 1 minus 0.9 divided by 2. because we have two of them. And if you do that, you get 0.05. Again, with your calculator, we learned how to do this. Do inverse norm and 0.05. The mean is 0 and the standard deviation is 1. If you do that, you get 1.644, but that's a special one. That's, they take 3 digits after the decimal point. So the left number is negative 1.645 and the right number is positive 1.645. If you want to directly find that, you have to know the area to the right of that value, which is zero point 0.9 plus 0.05 and is 0.95. If you do inverse norm 0.9501, then you get positive 1.645. Now the critical value, we always say one critical value, we take the positive one for our calculations. So we say the critical value or for 90% confidence level is, or the critical Z value, I put it for you, when you're using the normal distribution or the standard normal distribution is 1.645. Very common number, so 90%. The next common confidence level is 95%. So, and again, when I put CL, that is confidence level. Find the critical Z values same way. We know this area is 95%. You need to find the area in the tail. So it's 1 minus 0.95 divided by 2 is 0.025. You can do inverse norm 0.025 always. 0, 1, you get 1.96. So this number is or negative 1.96. This is negative 1.96, and that one is positive 1.96. So the critical Z value for 95% confidence level, Z sub alpha over 2 is 1.96. I did a third example here, find the critical value, Z values for 99% back because that's a very common confidence level also. So one more time, the area here is 0.99 because it's 99%. You find the area in the tail, and that's going to be 1 minus 0.99 divided by 2 is 0.005. And if you do that, you're going to probably see negative 2.58. But again, remember, that's a common one too. They take 3 digits after the decimal point, and that's because of reading the table. So, but we won't read the table in this video. And you don't need that since you have your calculators. So you get negative 2.575, and this one is 2.575. So again, calculator gives you this, but remember to use that one because physicians have been using negative 2.575 for the longest time. So, and again, that's from the table 2.575. The table is not needed for this video because calculator does the work. So remember the 3 common confidence levels. 90% confidence level, the critical value is 1.645. It's a very good idea to memorize those. 95% confidence level is 1.96. 99% confidence level, the critical value is 2.575. So now we learned how to find the critical values. Let's start with our first parameter. So, and I put estimating P, the population proportion. The confidence level, well, the confidence level will be given to, but the confidence interval is written like that. P hat is the sample proportion. And we said that's the point estimate for P. So you write P hat minus E, P and P hat plus E. P hat, you can calculate that by doing X over N. I'll do an example right now. You will see how we can find that. It's pretty easy and straightforward. The margin of error has this formulas. This is about over 2 times square root of p hat times q hat over n. I just want you to know, note square root of p hat q hat over n is the standard error for the population proportion. So uh, just know it until once we do all estimations and hypothesis testing, then I'll give you all the details where these formulas come from. But for now, let's just learn how to use them. P hat is sample proportion. Q hat is always 1 minus P hat everywhere in statistics. So please remember, N is the sample size. And of course, E is the margin of error. So I put an example here. I said, estimate with 90% confidence level the percentage of all our college students having a pet. In our college, we probably have 20,000 students, and I wonder what percentage of those students have a pet. So it's very hard to go and survey all 20,000 of them. So what I need to do is to pick a sample, and the best sample is probably our class. So I asked the question, how many of you, let's say we have 30 students in our class, and the question is, how many of you have a pet? 20 of you, 20 of students, so 20 of you say, I do. So P hat, the sample proportion, it's easy to calculate. I just take X, which is 20, divided by N. The sample size is 0.67. So I know right away 67% of the students in our class have a pet. How can we find out about all the college students? 20,000 students. So let's estimate. So step number 2, we have to calculate the margin of error. The margin of error, we said it's this about over 2 times square root of p hat 1 q hat 1 over n. What I said was 90% confidence level. So if you remember it, use it. This about over 2 is 1.645. If you don't remember, use your calculator, inverse norm, and always use the positive one. So 1.645 times square root of 0.67 p hat and 1 minus 0.67 over 30, which is the sample size. If you do that, you get 0.14. So to write the interval, you do p hat, which is 0.67 minus e.14 p, and the right side is going to be p hat plus e, which is 0.67 plus 0.14, and that's 0.81. 53% and 81%. This is called the confidence interval. The way you say that, you say if p hat is 67%, then we are 90% confident that p is a number between 53% and 81%. Don't forget, it's one number between these two numbers, which is the confidence interval. So the population proportion is one number, but it's a one number. So if somebody comes and says the proportion of students having a pet is 80%, according to this 80% is in the interval. So it could be true. Sometimes people use this. If you want to talk about the low proportion, then you can say 54%. High proportion, then you can say 80%. So please notice one thing. And from now on, if you see an estimation about anything, so if I said the first day of the class, I said 87% of people living in United States don't like their job. That was an estimation. So actually that's a number. So it all depends what confidence level they took and what was the confidence, the numbers in the confidence interval or the n numbers in the confidence interval. So these are little things you need to notice from now on when you hear, especially when politicians TikTok or on the news, you have to ask those questions to yourself. I did the same problem with 95%. So z sub alpha over 2 changed. We know z sub alpha over 2 for 95% is 1.96. We calculated that. So if I go back right here, and later I did it for 99% also. So if you do 95%, then you get 0.17. So this doesn't change, that changes. So the confidence interval in this case is going to be 50% to 84%. And I also did for 99%. Again, the z value changed. So you get 0.22. The interval is going to be 45% to 89%. Let's compare. 90%, that's these numbers are very close. As the confidence level goes up, then the confidence interval gets wider or larger. So something to notice. Calculator. So now I want you to get used to this from now because we're going to be using this in a TI calculator. So push stats, and then you're going to see edit calc, and the third one is test. Highlight test. And you can scroll down to A. It says one prop Z interval. So one prop Z interval, then the calculator is going to ask you for X, for N. So, and you just input those and the calculator will give you the interval right away. So it's pretty fast with the calculator. However, know the formulas also, please. Do not pick z-test. So it's not z-test, it's interval. Be very careful with this int because we're going to use this for the mean standard deviation, maybe not, or the difference of two means or two proportions. Last thing I want to talk about in this video is calculating the sample size. This was the formula for margin of error. So what you can do is isolate n from this formula. You can use some little bit of algebra, square both sides, cross multiply, and n is going to give you, the formula for n is z sub alpha over 2 squared times p hat times q hat over e squared. And we have couple of formulas. N equals to z sub alpha over 2 squared times p hat times q hat over e squared. If p hat and q hat are given to you, or you put n equals to z sub alpha over 2 times 0.25 over e squared. This is the case if p hat and q hat are not known. So you use 0.5 or is from 0.5 times 0.5 is 0.25. So you can still find the sample size. If p hat and q hat are not given, approximately take 0.5 for each one and multiply them, then you get 0.25. Let's do a couple of examples. 95% confidence level. Here, the margin of error we know is 0.02%. Find n. One more time, 95%, please remember, is 1.96. We don't have p hat and q hat, so I use 0.25. 1.96 squared times 0.25 divided by 0.02% is 0.002 squared, and if you get that, you get a large number, 24,010,000. So that's what we get. But let's do the second example. I think it's better because I want to go over a little detail. E is 3%, 99% confidence level, and we want to find n. So 99% is 2.575 squared times 0.25 divided by 0.03 squared, you get 1,841.84. Don't forget, sample size cannot be a decimal. Number of people, we can't say we have 1,841 people, 41.84 people. So what you do, you always take the next whole number, 1,842. Even if it's 1,841.001, take the next whole number. For the sample size, you always take the next whole number. Do not round it up, round it up. So, and these are some notes to find the critical values again. I'll upload this with the notes, the video with the notes, and please watch this recording couple of times. It's pretty straightforward using the formulas. Hope everybody have a good one. Take care of yourself, and I'll see you soon.